Now, the question is, how do we get these feature representations? And like before deep learning, or you can say like this data-driven approaches, there were a lot of local features which were developed. And these local features, the whole motivation was to actually try to represent these different concepts automatically. And once you have these features, you can use them to classify different images or to discriminate different images from each other. Okay, so SIFT is one such algorithm. And I think we have a lecture, a complete lecture to talk about the SIFT features. We have spin images, we have HOG features, and there are a lot of others. So this is just a small list, because earlier, like this is like classical computer vision. So everyone was trying to come up with these set of classical features. So it's not just like these 9. You will find like a lot of variations just for these set of features as well. So in the course, I think we are not going to cover all of those because again, it will take a lot of time. But we'll just try to cover some representative which are actually very useful, which were performing very good and are still used today. One of such features are like SIFT features and HOG features. So we'll try to cover these two. And the rest, I think, yeah, these we are not going to cover. Now, the challenge with these type of algorithms was these were like kind of handcrafted features. You'll have to think about like how to extract features like manually, and you need expert knowledge for that. And that's a challenge, because whatever feature you can derive using these algorithms, that is limited by whatever knowledge you have. Okay. So that has changed a lot. And I'm not saying these features are bad. These features still have like some very nice properties, and people haven't started looking back to like these features, but we have some like ongoing research where we have seen that if we try to integrate like these local features with like the deep learning paradigm, we can like do something much better than deep learning. And I won't talk like a lot about this because that's like an ongoing research, but just to give you an idea. Okay, so those local features, it was all feature engineering, which means you need some kind of domain expertise or some kind of domain knowledge to come up and design these features. Now, these days, like with deep learning, it has converted to feature learning. Okay, so we are not engineering these features in any way. All we are doing is we are trying to learn these features. Okay, and how these features will be learned. Half of this course is actually just focusing on that. And the neural network, the lecture we'll discuss today, it will start with like neural networks. That's kind of a basic building block of how these features can be learned. Okay, so the feature engineering, as I said, you need some kind of expert knowledge. And for feature learning, all you need is data. As long as you have sufficient amount of data, you can try to learn these features from those data points. Now, talking about data, like this is something, imagine it, all of you might have heard. This is a very large scale image classification data set. And this is like something from where this revolution of deep learning started in 2012. Okay, so it has like a lot of categories, different object categories, roughly around 1,000, and there are a lot of images. Earlier there used to be fewer, but it's actually growing day by day. So right now, roughly you have more than 14 million images. And in the testing set, you have around 100,000 images. So if you think about like those classical algorithms, it wasn't even like feasible to think about, how will you use that many images to maybe do some kind of feature engineering, or how you will like even test all these images. And the reason was the limitation of computation power. Okay, so the idea about learning these features is once we have these lot of samples, we try to learn from this from this data.